Good day to all our audience.
We're here to present our project, which is a supercapacitor powered torch.
The operation of the design system is summarized by the block diagram.
The charge controller circuit was implemented in order to reduce the charging time of the capacitor while protecting it from overcharging. This circuit is made up of the TL431 chip as well as the JFET to control this process. The TL431 is a very cheap and easy to use integrated circuit which changes its output voltage at the cathode when the input voltage reaches 2.5 volts. The JFET was used together with the TL431 as a simple switch to cut off the supply to the capacitor once its voltage reaches 2.5 volts. We also included an LED to indicate when the capacitor had reached maximum voltage. This method is advantageous because neither the current nor the voltage is limited when charging the capacitor. This resulted in a charging time of 1 minute and 10 seconds.
A boost circuit was built because it is an efficient way of stepping up the supercapacitor's voltage to the level required by the LEDs. The boost converter is also able to maintain constant output voltage during the exponentially decaying voltage of the supercapacitor. The built boost converter can boost voltages from 0.3 volts to the required level of the LED. The Tiny 45 micro was used as the MOSFET driver for the boost circuit. It dynamically changes the PWM in order to maintain constant output voltage at the output of the LEDs. The two brightness levels of the LEDs are selected using this micro when a push button is pressed.
The boost circuit can only operate at a minimum of 5 volts. This is greater than the maximum 2.7 volts of the capacitor. Therefore, a bootstrap circuit is required. The microcontroller operates at a minimum of 1.8 volts and is able to switch the low power transistor. By placing the transistor in parallel with the main power MOSFET, for a short period of time, the boost circuit can be run by the transistor. This provides a boosted output voltage that is able to power the micro with 5 volts. And consequently, the micro is able to switch the power MOSFET. The advantage of the transistor bootstrap is that it requires very few extra components, but can only work when the capacitor voltage is above 1.8 volts.